Excellent. Thank you. Thank you, Susan, for keeping us all on track today. It's been great listening to everybody, by the way. And as well, I'd like to thank the BCFCA for having me on board. And also, I would like to thank Chris for making me do a very deep dive into something I didn't quite understand yet. And I'm hoping that I'm able to shed a little light on the differences in the gap between 3 and 9 and 3. So a little quick history on myself. I've been with Laticrete now for a year and a half, just over. And I've been in the industry for several years. I'm a ticketed installer, like Chris said, red sealed, approved. So I have an affinity to that industry and those people, and so this was actually very good for me. And I'm hoping, and at the end of the show too, at the end of the slideshow, if anybody has any questions, have your iPhone ready. I have my contact card. It will show up on the last screen. You're welcome to, if you take your iPhone and scroll over the QR code, you'll be able to download my contact information instantly. Or just get a hold of BCFCA. They can get a hold of me. So we'll get started. So what I really wanted to highlight on is, and Chris went through a lot of the kind of the standards, which was great to have that. But now I want to go into where some of the disconnect is when we start showing up on job sites, and especially commercial. And that was where my forte was. I was a commercial installer in the union for many years, and ran into a lot of these kind of issues, and also got myself into some situations looking back that maybe were avoidable. So hopefully we'll be able to help you guys out with that. So we're going to be talking about the disconnect between the two divisions, 3 and 9. And the poor finished results that we end up with. And we're going to also discuss floor flatness, FF and FL, and the compromise of that. So to start off with, concrete, when you think of how it's poured, think of it in a few different stages. So there's going to be the pour consolidation, and that would be the vibrating. And then at that point, too, you're going to strike it off, and they're going to bull float it. Now, after that, depending on the level of finish that they want, we'd want to get that cut at that point. And we're going to discuss a little bit further on the reasoning behind that. Now, here's an interesting one. At this stage, too, we're going to do, after the cutting, we're going to wet cure. And a lot of times what that involves is just trapping the bleed water that's in the concrete, or possibly adding water. And that would be like sprinklers. We've seen that. We've seen them damp curing concrete. One of the things that's kind of interesting, especially being in BC, when you're driving around the province and you see that they're typically going to start their bridge repair work right about now. So with that, you'll see that they'll be doing design sections of repair, and they're also going to be wet curing all of that stuff. So the interesting part of that is that process has been going on for years. And you would think if that process had improved, they would have changed that process of getting away from the wet cured process. Well, they haven't, and there's a reason why. In your typical concretes, MPAs, say in an interior, a slab is going to be about 35 for residential. I'm not sure what it would be commercially, but sidewalks in that same sort of neighborhood, 35, 32, I believe, would be an interior slab. 35 would be an exterior concrete sidewalk. With that, they will take additives, polymers, different things, to moisture retention products to accomplish that MPA or PSI strength. That's just an easy translation. It's you can do that. It's 145 times by 145. So what you'll end up with is a concrete that'll go on a scale to get to MPa 35 based on the chemistry of it. If you take that exact same concrete and wet cure it, it's going to go past that and continue on that upward travel for quite some time. So very interesting, but also it's going to come into play a little bit later. So one of the other things to think about, and especially with the lower mainline, of course, you have a lot of metal deck over steel structure, and you're going to have deflection. So that deflection is the movement or the amount of movement that you're going to get. And that's going to start to create unevenness. And that's going to be where we will discuss what that ends up doing. So if you think about the different applications that you're going to be doing over top of these and the different requirements for them, they all have, different FFs, and I can rattle off some things to you. Like we have residential on hardwood, it's going to be, plus minus 3 millimeters or 1/8 of an inch. Carpet's obviously going to be a lot more. If you've installed, you realize the reasoning why. We can obviously go over top of a lot rougher surfaces in a carpet installation than you can in a super format or large format. I know Ames is going to present here shortly, and they're going to tell you some parameters, but for, say, a super format tile, which is going to be one edge being 15 inches or longer, that tile could be the tolerance on that could be as little as 5/16 or even less. So with that, that's a pretty flat floor we're looking for. So there's obviously a lot of difference there. So what we end up dealing with, and Chris mentioned this too near the end of his presentation, as the installer or installation company that's coming to site, you're going to be showing up 6, 8, 10 months later after the job's been poured. Who knows what kind of condition it's in and what's happened since the pour. The other thing that comes to mind that I was thinking about when I was going through this presentation is that's also when the budget's kind of blown. There's not a lot of money left in the job as far as trying to get this completed. So right away, you're not going to want to spend the money to correct this. There's also going to be a pushback as to who is supposed to repair it, and we'll discuss that as well. So as the concrete is placed, the division-free tolerances for that, they're measured within 72 hours. So that's going to be your floor flatness at that 72-hour mark, not when you're installing it. And we're going to discuss what ends up happening to concrete. And obviously, when you get there as the installer or the installation crew, there's a very high likelihood that you're going to reject what you find. And I'll discuss some of that as well. So some of the differences. And like I said, it was a pretty deep dive for me to try and get in and understand all of these things. So with Division 3, the specs for requiring are using F numbers. The interval points are 12 inches, basically everywhere except for 2 inches from walls or 2 inches from blockouts or anything like that. So that's pretty important when you think of that. And also at the end of and we're going to discuss that in a little bit deeper here too, at the edge of a pour, you can stay back 2 inches for doing your test on that. So again, that's going to become very important here shortly. So as you show up as the installer, the Division 9 takes effect. So as Chris mentioned, there's some standards. The manufacturers, the standard that you want to go with, they typically follow pretty close guidelines to what the NFC says. Of course, is going to be in that same ballpark. Everything is going to be, and I can rattle them off to you again. Like I say, plus or minus a 1/4 inch with a straight edge for carpet, hardwood's a little less, and the resilience a little less, and then there's specialty flooring, which is going to be, we'll discuss as well. So again, like Chris mentioned, that is the general contractor's job to correct, and that's going to be his negotiation to talk to the ownership and make sure that happens. So a few things to discuss about the FF and FL numbers. The specifications for the FF numbers are from the testing is kind of where I want to go with this. So that's going to be, they rely on this FF at the 72-hour number, FF and FL. Floor flatness is the FF number, and FL is the floor levelness number, and Chris kind of hinted on that as well. So what we're talking about here is a, shows, if you're looking at the FF number, what that shows is actually how well the worker finished that surface. So that's going to be that rippleness that Chris was referring to. If you think of the FL number, that's going to be how skillful the contractor was at setting the side forms. So that's your form work. And I can tell you from my own experience, over the last couple of weekends, I had two buddies that did hot tubs. And neither one of them had a 2x4 long enough to screed from side to side. And we had to kind of guess at it. Well, one of them we had to grind the middle later, and one of them we're going to have to fill. So that's a good example. Of course, it's just a hot tub. We're not talking about flooring here. So big difference. So just to reiterate what the FF numbers are, that's going to be measured at 1 foot intervals, 2 foot apart. Now I'm going to go into a little bit deeper with this to explain it a little better, because this is the one I wanted to wrap my head around so that you can understand and talk this talk. And I'm going to tell you why, because FF and FL numbers are both referred to by both divisions. Some are being referred to in even some flooring manuals with some of the manufacturer's products now, which I like, but we're going to discuss why that's kind of irrelevant as well. So the FL number, again, 1 foot increments on elevation difference over 10 feet. Now, this is where I want to really wrap my head around and understand it. So if we're going to look at the differences between FF and FL, what they actually are, that's a 2 foot increment we're looking at. And then we're going to move 1 foot and do another 2 foot, 1 foot increments, 2 foot intervals, and so on. So that is all the testing that we would do on FF. That's floor flatness. That's the rippliness that we're talking about. And if we're doing FL, we're going to be doing tests at 10 foot increments every foot. So that's the FL, and that's the difference. And one's going to show you your elevation, how weird your floor is, and one's going to show you how weird the ripples are. The higher the number, the better that is. Now I'm going to give you a little bit more advice on something here for my concrete finish friends. Hopefully some of them showed up. But one of the quickest ways to, and least expensive ways to improve your FF number is to replace your bowl float, which I used on the weekend, by the way. Nice big wide bowl float, but it wasn't wide enough to go from rail to rail, obviously. But the longer you can get that, the higher your FF number is going to go. So if you can replace that bowl float with a highway straight edge, which is, it can be anywhere from 14 to 18 feet wide, that's going to make a big difference. This alone can increase your FF number by 25 to 50%. And that, by the way, is going to be your F number, because if you don't see an FF, FL, they're typically going to be listed as FF is going to be first, FL is going to be second. That's why we always talk that languages of FF, FL. FF is always first, but if you don't see FF, FL, and you just see an F number, it's typically referring to the FF number. So that's another one that I found out as well. So in regards to the FL number, that accuracy in setting the forms is really what's going to affect that number as far as being level. Obviously, if you have one form that's higher than the other, you're not going to be very level. Unfortunately, my goalie for my hockey team, his hot tub is going to be a little out of level. Hopefully the water doesn't fall out. We'll see. So in that case, one of the other things you can do is you can also limit the distance between your formwork. So by getting down to a 25-foot number, and then now when I say that, you guys have probably all seen very large jobs where their formwork is wall to wall, and of course, like Chris had mentioned too, laser screeds do help, but keeping that formwork to 25 foot, and sometimes in some cases too, even there's good pipe screeds or pipe formwork that you can use that's partway through your pour. That helps out tremendously as well. But both of these are going to add cost. So the higher the number you want in your FFFL, the higher the cost is going to be, obviously. So a little bit of the history on the floor flatness timeline. So back in the early 1900s to about 75, floor flatness was not really all that tremendously important. It wasn't until 75 where narrow track aisles warehousing, where we're trying to stack boxes way up high, and if that becomes a big problem when your forklift is obviously moving around. We've all seen this even on smaller scales. Imagine now if you're going to be 60 feet in the air, how much more important that becomes. So that all started in about 75. Alan Face was actually the one who developed the F numbers. The laser screed was invented in 85. Alan then started publishing his results. ASTM took this on and released the FF number standards. And some of the documents that we still follow, ASTM 1155 on testing analysis, they're referred to it even in NFCA catalogs as well. So the American, some of the guidelines that you look at for concrete finishing, placing, and everything else are going to be your American Code Institute, or American Concrete Institute, that's the ACI, and also the Canadian one that is pretty much follows, they're kind of playing the same category, or the same kind of sandbox, is going to be the Cement Association of Canada. It's not referred to on this timeline, but it is referred to in the NFCA as well. And the ASTM E1155 with funny it doesn't mention it here because this is kind of the American history, but if you look at the E1155M, which refers to metric, is all that would be. So if you think of those waves in the floor being less flat, it's also, I jumped ahead there. As you start to flatten them out, it's a little more flat. You can still have waves, and some flooring is still going to work just fine with it. But if you want to get true that's a funny word. I even had to look it up. It's a Latin word, planarity. And that's what you really need for some of these things like MRI rooms and high warehouse locations. Now, here's where we're going to start talking about, and I'm going to tell you, in the beginning, I was like, these concrete guys got to do a better job. And I was, being a flooring guy, and also started to understand and remember some of the job sites that I've been on and some of the things that I ran into. They started to pop up. So sag, creep, curl, new concrete, it happens months after a pour. And I get it, we're testing 40 or 72 hours or less after a pour is when the concrete guy gets his approval that his slab's good to go. Why do these things happen? Well, if you think of, you've all taken that that yellow dish sponge, and you've wiped your dishes and you've left it on the counter, and over half an hour, it starts to curl, and you'll get this nice little bow in it. Very similar to what a concrete slab does. Very similar to what Chris was actually talking about with the hardwood that was heated up on the surface and it started to crack and everything else. As it's losing volume and density on the surface and not on the bottom, it wants to curl. Now, if we go back to that slide at the beginning when we were talking about wet curing and the importance of that, well, if you wet cure a concrete slab, you're not losing volume. And you're keeping that volume in by keeping the water in it and not allowing it to escape. What also ends up happening is those concrete fibrils start to grow longer, and they really start to grab onto each other, and they start to create a much stronger concrete matrix. I had to jot this number down because I was absolutely amazed by it. Concrete has the ability to stretch 0.002 inches per foot once it's cured, and that means it's not being restrained as well. So that doesn't sound like a lot, but concrete shrinkage is actually about 0.006 or 25% more. I know those are just throwing numbers out there, but what we're really saying is in that very beginning of a concrete pour, if you're not wet curing it and it starts to shrink because that volume starts to be lost, basically, that shrinkage is going to happen before the strength is gained. So that's where the problem lies. So another thing I wanted to touch on, and this is an interesting photo here, is actually a job I went to. That was I think it was about 4 weeks old, and that curl that's on that was actually the stairs of a pour. It's a lightweight concrete, and the entire floor was radiant heat. You had about 3,000 square feet of radiant heat, and it was all lightweight concrete, and it all cupped like this, and it was all broken everywhere, and it was a mess, and it all ended up getting removed. Now, when I started looking at concrete curl, and it's not relevant to, by the way, that's not relevant to being a lightweight. That still happens in all concrete. So when I started doing this deep dive into this, one of the things that came up was years ago, there was the concrete industry was actually pushing back a little bit on vapor barrier. And Chris touched on moisture vapor as well. And as that comes out of the groundwork, especially on, like, if you're on grade and slabs like that, the concrete industry was actually looking at it as when you put that vapor barrier on the bottom side of your slab, you start to get very quick curling, and that's more to do with the plastic being directly below. And why that's happening is because the moisture cannot escape in both directions. It can only go up. So it had a tendency to curl quickly on the edges. Minor, but quickly. Now, what ends up happening if you don't do that is that curling is actually much more substantial and much more aggressive. So a couple things to think about, and I'm just checking my time here, so I'm going to have to jump ahead or speed things up a little bit, being a bit of a flooring nerd here, I guess. So some of the things to think about with these FF and FL numbers as they go up, like I said, it's better to have a higher number. But when we get into MRI rooms, television studios, things like that, our numbers have to go up tremendously to get to a flatness that they're not going to affect the equipment. So that's why we're looking at that. Your typical flooring that we deal with in the flooring world is going to be around F35, FL20. That's also a little bit less than what a thin set requirement on a typical installation would be, but it's actually probably going to be, in my opinion, this is outdated. I think with the new format, large super formats, those are actually much more sensitive to needing a higher number. So as well, I wanted to touch on a couple other things. Most manufacturers will provide you with a system where, and I like this idea, by the way, because I'm going to tell you some stories about when I was, because I went from flooring to move to the interior, and I became a carpenter. And at some point, not too long after that, I ended up in northern Alberta, and I was the job super on the site. I was the foreman. And we poured some construction joints, which is basically just a well-placed joint. It's going to be in a strategic area because we can't pour wide enough. That's what a construction joint would be in concrete, just because the size of the job was beyond the capabilities of the crew. So we poured that. We formed it up. The company came in, poured it. And I was thinking to myself, as an installer, floor layer, I'm like, I'm going to watch these guys and make sure that they don't end up with this big lip at the control joint, like I'd seen so many times as an installer. which used to drive me crazy. Well, sure enough, they poured it and it was fine. And I'm like, hey, they did a good job. And about 3 weeks, 4 weeks later, it was all cupped and curled, and it was fine when they left. So as much as I wanted to pick on the concrete guys today because I'm a floor layer, the reality of it is they're justified in having their numbers done at 72 hours because it will happen. It's going to move. The concrete ends up being its own animal. So getting back to that, I like the idea of striking off your floor, bull floating it, nice wide bull float, leave it, and then come back and level it, cap it. One of the other things I wanted to touch on, because I think these guys need some help too, resinous coatings. If you think of the flooring world, when I first started, moisture control was just coming into play, and then now it's very well known. There's lots of products for it, but the guys I think that need some help right now are going to be our coating guys. I think they're at their infancy. They look like they're grown up and know what they're doing, but the reality of it is this is a very raw industry that doesn't quite understand everything that's going on with concrete quite yet. As well, I mean, that industry is growing. We've got it in grocery stores. We got it residential, actually we do have it residential. But we got it industrial. It's in kitchens. We're looking at a lot of that stuff. So just to speed it up here a little bit, I'm very thankful that I was asked to present today. I believe it's a great industry, and looks like it's going to have some more success coming. We had about a 5% increase in tile and stone. I think this year is what the industry is looking at. So there's systems that we can help you with. We have a full line of leveling products as well as our SuperCap high delivery system. And I want to thank you all. And that's my contact information if you'd like to scan that.
Thank you, Doyle. Fantastic presentation, very professional. Okay, so I'll just see if there's any quick questions because we have about a minute before we wrap up here. I don't see any questions there. Okay. Well,